In this video, we're going to add API key authentication to the REST API we developed in an earlier video using the Slim PHP micro-framework. We're going to add a web interface, all still using the Slim framework, where the user can register for a new account, then log in to view their individual API key. They can then use that key to authenticate to the API. We'll start from where the previous video left off, using the code and database we had at the end of that video. If you do need the code and/or the database from that video, it's available in this repository, and there's a link to this in the description. As in the previous video, I'll be using HTTP as the API client, with the code running at the slimapi.localhost address, using a virtual host. Let's start by requiring an API key to access the API. At the moment, we can make any request to any of the endpoints without having to supply any authentication. Let's do this using middleware. So in the source app middleware folder, let's make a copy of the add.json-response-header.php file and name the copy requireAPIKey.php. In here, we'll change the class name so it matches the name in the file name. In the body of the invoke method, we still want to handle the request and return the response, but without adding the additional header. Before we do that, we want to check for the presence of an API key in the request. There are a couple of ways we can do this. First, let's get it from the URL using the query string. To get the query string parameters from the request, we use the getQueryParams method. This returns an array of the key value pairs from the query string. So let's check to see if there's an element with an index of API key. If not, for now, let's just exit the script with a message. To test this, in the index file in the public folder, at the top, let's add a use statement for the middleware class we just added. Then, at the end of the root group for the API endpoints, let's add the requireAPIKey middleware using its class constant. Now when we make a request to one of the endpoints, we get the API key missing message in the response body. If we add the API key to the query string, we go back to getting the original response. So in the middleware, if the API key is missing, instead of exiting the script and printing out a message like this, we need to return a response object. We could use the response object we get from calling the handler. But the idea with this middleware is that if the API key is missing or invalid, we return a response without running the handler. This handler is just retrieving some data, but imagine that it's doing something else that we don't want to happen if there is no API key, for example, saving some data. So we need to create a new response object. As this is a dependency, we'll inject it using the constructor method, so let's add that. One way to get a response object would be to specify one as an argument to the constructor. However, let's do it using a factory instead so we can see how that works. The Slim PSR7 package that we added earlier contains a response factory class, so let's add a use statement to import that into the current namespace. Then we can specify an object of this class as a constructor argument. Then, in the invoke method, instead of exiting the script with a message, let's create a response object by using the createResponse method on the factory property. We can then get the body of that response and write a JSON encoded message to it. Finally, we'll return the response with a status code of 400 for bad request. The API will require an API key, so without it, the request can't be processed. Hence, the request is invalid. Let's give that a try. If I make the request without the API key, now we get a response with the JSON message in the body and a status code of 400. If I add the API key, we get a 200 response with the JSON data. Now that we've checked the request contains an API key, we can check its value. For now, let's just compare the supplied value to a hard-coded string. So if the value supplied in the query string doesn't equal the string ABC123, again we want to return a response. So let's create one using the factory. then write a message to the response body and return the response with a status code of 401, which is the code for an unauthorized request. So now if we make the request with an API key that doesn't match the string we specified, we get the 401 response with the invalid API key message in the response body. If we specify the correct key, we get the JSON data as before. Passing the API key in the query string is a valid way of doing it, so if you want to do it this way, that's no problem. Let's look at another common way of doing it, however, using a request header. So instead of using the query string, first, to check if the API key is present in the request, we'll use the hasHeader method on the request object, checking for a header called xAPI-key. Note that there's no standard request header for sending an API key, but it's common to use xAPI-key. I'll leave the query string code in there commented out, so it's present in the source code. Then we need to check the value of the header. If we just get the value of the header using the getHeader method on the request, this returns an array, as a single HTTP header can have more than one value. We could do this and check each array element, but to keep it simple, we can use the getHeaderLine method, which returns a string. So instead of checking the query string parameter, we'll get the value of the xAPI key header from the request using that method, and compare this to the same hard-coded value we used before. Let's give that a try. If I make a request with no API key, we get the bad request response as expected. To add a header to the request using HTTP, we include it after the URL, separating the key from the value with a colon. So if I include the xAPI key header, but with an invalid value, we get the 401 unauthorized response. If I include the correct value, then we get the 200 response with the JSON data. Note that the header key is not case sensitive, so if I pass in the header in all lowercase, but with the same value, it still works. If you're using Postman, you can add the API key header in the authorization section. Now we have the mechanism in place to require an API key, we can remove this hard-coded value and add user accounts that each have a different API key. To do that, let's add an interface that allows a user to register a new account. At the moment, all the routes are defined in the index.php script in the public folder. Before we add more routes, let's move these to a separate file so that it's clearer. So let's add a new file to the config folder called routes.php. In here, we'll add the PHP opening tag and enable strict type checking. Then, in the index.php script, we'll select the existing routes, cut them, and paste them in the routes.php script. Back in the index script, we also need to move these use statements for classes we're using in the route definitions. Then, back in the index again, at the point that we cut the route definitions from, we'll require the routes file that we just added. Let's make a request to the API to make sure it still works, and it does as before. Now we can add some more routes. At the moment, all the routes here in the routes configuration file are in the API group, so the URLs will start with the API segment. These are all routes that are part of the REST API and will respond with JSON. Let's add a web interface starting with a home page. So in the source app controllers folder, let's make a copy of the product-index.php class and call it home.php. In here, we'll rename the class to home, and this won't have a dependency of a product repository object, so we can remove this use statement and the constructor method argument. We'll leave the constructor method itself as we'll need it shortly. In the body of the invoke method, let's delete this first line that we don't need and set the body variable to the literal string hello world. Then, in the routes configuration file, let's add a use statement for the home controller class we just added. Then a get route for the site route, which will run the home controller. As this controller is a single action controller with an invoke statement, we don't need to specify the method in this route. Let's give that a try. If I go to the root URL in the browser, we get the Hello World message, but we also get a JSON parse error. The response still includes the JSON content type header. In the index.php script, we're adding the add JSON response header middleware for all requests. So we only add this for API requests. Let's remove this from here. And from the top of this script, we'll cut the associated use statement for this class. Then in the routes file, we'll paste the use statement and add this middleware to the API group. Note how I'm using the class constant to specify the middleware instead of creating a new object of that class. You can do either, but I think using the class constant is clearer. Now in the browser, we get the response without the JSON header. Let's just check we still get the JSON header when we make a request to the API, and we do. However, in the browser, if we go to a page that doesn't exist, we get a 404 response, but it's in JSON format. This is because in the index page, after we add the error middleware, we're forcing the content type to JSON for every request. Previously, we only had API requests, and every response was in JSON format. Now we have a mixture though, we can remove this line. To clean this up a bit more, we can also remove this line where we get the error handler object into a variable, and we no longer need to assign the error middleware to a variable either. Now in the browser, for a URL that isn't found, we get the error details in HTML format. If we do the same thing using the API client, however, we get the response in HTML. The Slim framework will return the appropriate response content type automatically, but it does this based on the request headers. Using HTTP, we can specify the JSON content type and accept headers using the -j flag. Now we get the response in JSON format. Note we don't need to specify this for every request when developing. This is just to demonstrate how Slim will adapt the response based on the request headers. If you're using Postman, you need to set the accept header to the JSON media type, then the response will be in JSON. Now we have a home page responding with the correct content type, we can add some HTML content to it. At the moment, the home controller is just writing this literal string to the response body. Instead of hard coding some HTML in here, we'll put it in a separate view file. So let's create a new folder in the root of the application called views, and inside that folder, a new file called home.php. This won't be a class that will auto-load, so the case of the file name doesn't matter. In here, let's add some very basic HTML to show a page title and a heading. Now we need to render this view file from the controller. Slim provides a PHP view component designed specifically for rendering PHP view templates. There's also a twig view component that helps you to render twig templates. We'll keep it simple, however, and just use plain PHP templates. So on the command line, let's install the Slim PHP view package using Composer. Then, in the home controller, let's add a use statement to import the PHP renderer class, and add an object of this class to the constructor method's arguments. Then, in the body of the invoke method, we can delete the existing contents, and replace them with a call to the render method of the PHP renderer property, passing in the response object and the view template file name. This returns a response object, so we can just return the result of this method call directly. In the browser, however, we get an error. Specifically, the home.php template wasn't found. When we create the PHP renderer object, we need to tell it where the view templates are. As this object is being created automatically by the dependency injection container, we need to do this in the definitions config file, just as we're doing with the database object. So in here, let's add a use statement for the PHP renderer class. Then a definition for that class that creates a new PHP renderer object, passing in the relative path to the views folder as an argument to the constructor. We can then return that object. Now in the browser it works, and we see the home view template. Next, let's add a sign-up page where the user can register for a new account to get an API key. Let's start by adding a new controller. Let's make a copy of the home controller and call it signup.php. In here, let's change the class name to signup, and we'll have several action methods in this controller. So let's change the name of the invoke method to new. In the body of the new method, instead of home.php, let's render a view template called signup.php. Then let's create that file in the views folder. For the content of this file, we need the HTML for a sign-up page. This will include code common to the home page, such as the HTML head section. Instead of repeating ourselves, we can use a feature of the PHP view package that allows us to create a common layout file. So let's create a new file in the views folder called layout.php. In here, we'll put the code from the top and bottom of the home.php view. To render the content from whatever template uses this layout, we output the content variable. So the home.php view now just contains the heading tag. To configure the package to use the layout template, in the definitions file where we create the PHP renderer object, we call the setLayout method, passing in the file name of the template. In the browser, this still works as before. If we view the source, we can see the contents of the layout template with the contents of the home template. Now we can add some content to the signup.php template. We'll add a heading and a form that uses the post method and that submits to the /signup URL. We'll add a route that handles this URL shortly. Let's add inputs and associated labels for the user's name, their email address, password, and a password confirmation field, so that we can check they entered the password correctly. We'll end the form with a submit button. We already have the code to render this template from the new method in the signup controller. So next we need to add a route. In the routes config file, let's import the signup controller into the current namespace. Then add a get route for /signup that will run the new method in the signup controller. Finally, before we view the form, in the homepage template, let's add a link to the signup page using the route we just added. Let's give that a try. On the homepage, there's the link to the signup page, and if I click it, there's the signup form. To quickly add some styling to this, I'll use my current favourite classless style sheet, water.css. To add this, all we need to do is copy this style sheet link and paste it in the head section of the HTML in the layout file. Now in the browser, the signup form looks much nicer. Now we can add the functionality to process this form when it's submitted. In the signup controller, let's add a new method called create with request and response arguments that returns a response. Then we can get the form data with the getParsedBody method on the request object, just like we did in the create method in the products controller. For now, let's just check that that's working by printing that out and returning the response. In the routes configuration file, let's add a post route that matches the signup URL that runs the create method in the signup class. Let's try that by entering some data into the form and submitting it, and we get an array containing that data. Before we can save this data into the database, we need to validate it. In the products controller, we're using the Valitron package to validate data, so we already have this package installed. So back in the signup controller, first let's add a use statement for the Valitron validator class, and add an argument for an object of this class to the constructor. Inside the constructor method, we can initialize the validator by adding some validation rules. To do this, we call the mapFieldRules method on the validator property, passing in an array containing the validation rules. We'll make the name required, the email required and also a valid email, the password required with a minimum length of 6 characters, and the password confirmation required and that it equals the password. Check out the Valitron documentation for the details of how to add further validation if you need it, for example, a more complex password format. In the create method, once we have the data, we can set the data in the validator object with the withData method, passing in the data array. Then, to validate the data, we call the validate method. If this returns false, for now let's just output the error messages from the validator. Now if I submit the form with no data, we get an array of validation messages. Note that there's one array element for each field, and the value itself is an array, as there can be more than one error message for one field. Instead of outputting the error messages like this though, it's more user-friendly to redisplay the form. So let's render the signup.php page as we're doing above, and to pass data to this view, we add an array argument to the render method, passing in the error messages with a key of errors. This will become the variable name in the view. Then, in the signup.php view before the form, let's check to see if the errors variable is set. We need to do this because when we first display the form from the new method, we don't pass any errors to it, so this variable won't be set. Then, if the variable is set, let's display an unordered list containing each error message. Remember from the output we saw just now that there's an array element for each field, and each element's value is an array of messages. Let's give that a try, starting from displaying the page for the first time, just to make sure that works as before, and it does. If I submit an empty form, now we get the validation messages printed out just before the form. If I supply a valid value for one of these, then that error message disappears. Note, however, that the original value I entered into the form is lost. It would be more user-friendly to redisplay the form with these values, so the user doesn't have to enter them again. So we have access to the original data in the view. In the controller, let's pass the array of form data to the view in addition to the errors. Then, back in the view, for the name input element, let's add a value attribute with a value that's the name element of the data array. As with the errors variable, this might not be set. So the simplest way to deal with this is to use the null coalescing operator to provide a default value of an empty string if so. Finally, as this is untrusted input coming from a user, we need to escape this with the HTML special chars function to prevent code injection. Let's do the same for the email input. We won't do it for the password type fields though, as the values for these are shown as asterisks, so it's difficult to edit the values of one of these fields. Let's give that a try. Now if I enter a name but leave the other fields blank, when the form is redisplayed, the value I entered for the name field is kept. Likewise for the email address. Also, if I enter some characters that would otherwise be interpreted as HTML into one of these fields, these are escaped and displayed as they were entered. If I enter valid values for all the fields, then we get the array with these values. So now we know these values are valid, we can save them to the database. Before we can do that, we need to make a couple of changes. First, we need to hash the password. It's best practice to store the password as a hash. This way, if the database is compromised, an attacker doesn't have the plain text passwords. The standard way to do this is to use the password hash function, using the default algorithm. Then we need to generate an API key. To do this, we need a random string of characters. So let's use the random bytes function to get 16 random bytes, then the bin2 hex function on that to convert these to printable characters. Let's set the API key element of the data array to this value. Let's just have a look at what values are generated if we submit the form with valid data. And there we have the password hash and the generated API key. This is the value the user will use to authenticate with the API. Now we can save these details to the database. To store user data, I've added a table to the database called user that has an ID column to identify each row, and has columns for the name, email, password hash, and columns for the API key and API key hash. We'll see why we have both API key and API key hash columns shortly. The ID column is set to auto-increment, so values for this will be assigned automatically. There's also unique indexes on the email and API key hash columns. There's a script in the code repository for this video that adds this table to the database, and there's a link to this in the description. For the code to store values in this table when the user signs up, let's create a repository class. So let's create a new file in the source app repositories folder called userrepository.php. In here, we'll add the PHP opening tag, enable strict types, and add the namespace and class definition. As with the product repository, this class has a dependency on the database class. So let's add a use statement for that, and pass in an object of that class using the constructor. Then let's add a create method that has an array of data as an argument and doesn't return any value. Inside this method, we'll write the SQL to insert a value into the user table we just created. We'll specify values for all of the columns, apart from the ID, which will have a value assigned automatically. As this is untrusted data, to avoid the risk of an SQL injection attack, we'll use a prepared statement with placeholders for the values. Then we'll get a connection to the database using the database property and prepare the statement. Then we can bind values to the placeholders. I don't need to specify the data types as these values are all strings, and that's the default. Finally, we'll execute the statement. Then, back in the Signup controller, to use this class, first let's add a use statement for it. Then we can add an argument to the constructor for an object of that class. Then, at the end of the create method, instead of printing out the data, we'll call the create method on the repository object, passing in the data. Before we do that, just to take care of the API key hash column that we're not using yet, as this doesn't have a default value in the database, let's add an element to the array with a key of API key hash and a value of an empty string. Then, after we've called the create method, for now let's output the API key that we've generated and saved to the database. Let's give that a try. If I enter valid data into the signup form, we get the API key printed out. In the database, there's the user record inserted successfully, with the same value for the API key. Now we can use this key to authenticate access to the API. We're authenticating the API key in the require API key middleware. So instead of matching the supplied API key to this hard-coded value, we want to look in the database to see if the supplied key matches any of the records there. First, in the user repository class, let's add a new public method called find. This will have a string argument for the column and a value argument. We won't add a type declaration to this argument, so we can supply values of different types. This will return an array or a Boolean value. In here, we'll write some SQL to select a record where the supplied column argument matches the value. As the value could be untrusted input, we'll use a placeholder. Then we'll get the database connection, prepare the statement, and bind the value of the value argument to the placeholder. Then we'll execute it and call the fetch method, returning its return value. This will either return an array containing the matching record, or Boolean false if no records matched. Then, in the require API key middleware, let's import the user repository class into the current namespace and add an argument of that class to the constructor. Then, in the invoke method, instead of comparing the API key from the header to a hard-coded value, we'll assign it to a variable. Then we can call the find method on the repository object, passing in the column name for the API key and the variable. If the value returned is false, then no record was found, and we return the invalid API key response. Before we try that, let's copy the API key that we just generated when we created a new user account. Then with the API client, let's make a request with that key. We get the JSON product data as expected. If I change the value of the key, then we get the invalid API key response. So now we're authenticating API requests with API keys from the database. However, we're currently storing the API key in the database in plain text. Although we're not using it yet, we're storing the account password as a hash instead of plain text for security. If we store the API key in plain text in the database, then if the database is compromised, the attacker would have a list of API keys with which they could authenticate to the API. So let's store a hash of the API key in the database instead. To do this, we'll use the hash hmark function, which requires a secret key. We only need to do this once. So to generate a secret key, let's pick one of the many sites available that will do this and copy one of these values. Then, in the .env configuration file, let's add a new entry called hash secret key, setting its value to the string we just copied. Then, in the create method in the signup controller, instead of setting the API key hash element to an empty string, we'll use the hash hmark function with the SHA-256 algorithm to generate a hash of the API key. As for the API key field itself, for now, let's just set that to an empty string. Then, in the require API key middleware class, after we've got the value of the API key from the header, let's generate its hash using the same algorithm and key. Then we can look up the record in the database using the API key hash field and this value. Before we try this, I'll just delete the existing record from the user table in the database so we don't get confused about which record to use. Now we can sign up for an account again. When we submit the form with valid data, we get the API key. Let's copy this, then make a request to the API using this value. The request is authenticated successfully and we see the expected JSON data. In the database, there's the user record with an empty string in the API key column and the hash of the API key in the API key hash column. Let's copy this value and try to use it to authenticate to the API, and we get the invalid response. So now the API keys are stored safely in the database. At the moment, when creating a user account, we are immediately showing the user the API key that's been generated. You could do this if you like, and is a simple way of doing it. You could even email the user the API key so they have a copy of it. However, as the key is now stored as a hash, we have no way of retrieving the API key if the user loses it. To make it more user-friendly, let's add a page where the user can log in and see their API key. Let's start by adding a login controller. To do this, let's make a copy of the signup controller and call it login.php. In here, let's change the class name to login. We don't need to do any validation, so we can remove the use statement for the validator class and the argument and body from the constructor method. We do need the renderer class and the user repository, so we'll leave those. In the new method, instead of rendering the signup view, let's render one called login.php instead. To create that view, in the Views folder, let's make a copy of the signup.php view and call it login.php. Note that you can of course organize these view files into subfolders if you prefer, but I'll keep it simple and just leave them all at the same level. In here, let's change the heading to login and remove the error display code. In the form, we'll change the action to /login and remove the name and password confirmation fields, leaving just the email and password fields. Finally, we'll change the text of the button to login. Then, in the root configuration file, let's add a use statement for the login controller class, then a getRoot for /login that runs the new method in that class. While we're here, let's also add a postRoot that will run the create method. Finally, in the home view, let's add a link to the login page. Let's give that a try. If we go to the home page, there's the link, and there's the login page. Next, in the login controller, in the create method, let's remove the content that came from the copy of the signup controller, apart from the first line where we're getting the data from the form. Then, let's use the find method on the user repository to find a user based on the email address supplied in the form. We can verify the password with the password verify function. So if the user variable contains a truthy value and the supplied password matches the password hash in the user record, then the login is successful. In this case, for now, we'll just redirect back to the home page. To do that, we return a location header with the path to the home page, along with a 302 status code. If the login details are incorrect, we'll render the login template again, and we'll pass the original data from the form, along with an error message. In the login view, we're already using the data variable to display the originally submitted value. To show the error message above the form, let's check if this is set, and display it inside a paragraph element if so. Let's give that a try. If I submit invalid login details, the form is redisplayed with the error message, and the value of the email field is maintained. If I submit correct details, we're redirected to the home page. Now we can actually log the user in. We'll do this using the session. To do this, first we need to make sure the session is started. Now we only want to enable sessions for the pages in the web interface, not for the API. The best way to do this is in some middleware. So in the app middleware folder, let's make a copy of the add JSON response header file and call the copy activatesession.php. In here, let's change the class name accordingly. In the body of the invoke method, let's remove the with header call. Then, at the top of this method, let's call the session start function to start the session. Just to make sure we're not calling this if a session is already active for some reason, let's check the session isn't already active with the session status function. Then, in the root config file, let's add a use statement to import this middleware class into the current namespace. We want to enable this middleware on all the routes that are part of the web interface. So, as with the API group, let's put these routes into a group with an empty string for the root path argument, as we don't want to change the paths. Note how we need to change the app variable to the group variable inside the group. Then we can add the activate session middleware to this group. Now when we view the home page, we don't see any difference, but if we use the web developer tools to look at the cookies, we can see that the PHP session cookie has been set. Now we can use the session to enable login. In the create method in the login controller, if the email and password are correct, let's set a value in the session containing the ID of the user record. Then in the home.php view, so we know if a user is logged in or not, let's add an if statement around the signup and login links. If the value in the session for the user ID is empty, then we'll display these links as before. If not, let's display a link to a logout action that we'll add shortly. Let's give that a try. If I refresh the home page, it doesn't change as we're not currently logged in. If I log in, we're redirected back to the home page, which now shows the logout link. Now we can add the functionality to log the user out. So here in the login controller, let's add a new method called destroy, with the usual arguments for the request and response, and returning a response. In here, we'll call the session destroy method to clear the session, then redirect back to the home page by returning the response with a location header and a 302 status code. Then in the root configuration file, let's add a getRoot for /logout that runs this method, making sure we add this inside the root group that includes the activate session middleware. Let's give that a try. On the home page, we see the logout link as we just logged in. If I click the link, we're redirected back to the home page, and the links change to the sign up and login links. Now the user can log in. Let's add a page where they can view their API key. Let's start by making a copy of the login controller and calling it profile.php. In here, we'll rename the class accordingly. We won't need the user repository class, so we can remove the use statement for that, and the argument from the constructor method. Then let's rename the new method to show, and inside that method render a view template called profile.php. We'll delete the create and destroy methods. In the views folder, let's create a new file called profile.php, and in here let's just add a heading for now. In the routes config file, let's add a use statement for the profile controller, then a route inside the activate session group that runs the show method in that controller. Then in the home.php view, let's add a link to this page inside the block that's shown when the user is logged in. Let's try that by logging in, and there's the profile link, and clicking it takes us to the profile page. However, if we go back, then log out, we can still access the profile page by going to /profile in the address bar. If we're going to show the user's API key on this page, we need to ensure that the user is logged in before they can access it. Let's do this with some more middleware. We'll start by making a copy of the require API key class, calling it requirelogin.php. In here, we'll change the class name accordingly. We'll leave the constructor as it is, as we'll need the response factory and user repository objects, and we'll delete the contents of the invoke method. Instead, in this method, first let's check to see if the user ID is set in the session. If so, let's use the repository property to find a user record based on that ID. If this returns a truthy value, then we can handle the request and return its response. Otherwise, let's use the factory to create a response, write an unauthorized message to the body of that response, and return a 401 status code. Then in the routes configuration file, let's import this middleware class with a use statement. Then we can add this middleware to the route that shows the profile page. Let's give that a try. We're currently not logged in, and if we try to go to the profile page, we get the unauthorized response. If we log in, then we can access the profile page. Now we have this page, we can display the logged in user's API key on it. However, we can't access the plaintext API key as we're storing it as a hash in the database. We don't want to store the plaintext version of the API key for the security reasons we covered earlier. So instead, we'll encrypt the API key before we store it. This won't replace the hash, as we still need that when authenticating using the key. For encrypting the API key, I'm going to use this PHP encryption package. I'll go into detail about different techniques for encrypting strings in PHP in another video, and there's a link to that in the description. To install this package, we'll use Composer on the command line. While we're on the command line, we'll use the script that comes as part of this package to generate a random encryption key. We can then copy the value that this prints out. In the .env configuration file, let's create a new entry called encryption key, and for its value, paste the string we just copied. Then we need to save an encrypted version of the API key when we sign up a new user. So in the signup controller, first let's add a couple of use statements at the top to import the classes from the encryption package that we're going to use. Instead of injecting an object of this class in the constructor, the methods we're going to use are static, so we can just use these classes directly. So in the create method, after we create the API key, to use this package, first we need to create a key object using the static load from ASCII savestring method on the key class, passing in the value we just added to the .env file. Then, instead of assigning an empty string to this variable, we'll encrypt the API key by calling the static encrypt method on the crypto class, passing in the API key and the encryption key object. Let's give that a try. Note I deleted the existing record from the database before doing this, so it's clearer. If I sign up with valid data, we get the API key printed out. Taking note of what this value looks like, if we look at the new record in the database, we can see the API key column contains a different value. This is the encrypted version of the API key. Now you might be thinking, why are we effectively saving the API key twice in the database? Well, using this encryption package results in a different ciphertext each time, even if the plaintext is the same. So when we authenticate the API key in the middleware, if we encrypted the supplied value using the same encryption key, we'd get a different value to the one in the database, even though the original key value is the same. Now we have the encrypted API key in the database, we can display it on the user's profile page. So in the profile controller, let's import the two classes we need from the encryption package into the same namespace. Then in the show method, we need to get the user record for the user that's logged in. One way to do this will be to use a user repository object to get the record using the user ID in the session. However, we're already doing this in the require login middleware, which runs before the show method in the profile controller. So to avoid making an unnecessary repeat request to the database, we can pass this along with the request. So once we have a user record, we call the withAttribute method on the request, passing in a key and a value. This will return another request object, which is what we pass along the chain. So now in the profile controller in the show method, we can get this value from the request with the same key. Now we can decrypt the API key in this record. So as before, let's create a key object from the encryption key value. Then we call the Decrypt method, passing in the encrypted API key value from the database and the key object. Then we can pass this decrypted value to the view. Finally, in the profile.php view, let's display the key. Let's give that a try. If I log in and go to the profile page, there's the decrypted API key. Let's copy that and use it to authenticate an API request, and it works. Now the user can get their API key by logging in and viewing their profile. We no longer need to display this as soon as they sign up. Currently, in the signup controller, at the end of the create method, we're writing out a string containing the API key. As this method runs in response to a POST request, we should also really change this so we use the POST redirect get pattern. Otherwise, if the user refreshes the page after signing up, the sign-up form data will be submitted again. So instead of this, let's redirect to a sign-up success page. First, let's add a new file to the views folder called signupsuccess.php. In here, let's add a heading and a message that includes a link to the login page. Then, back in the signup controller, let's add a new method called success with the usual arguments and return type. Inside here, we'll render the view file we just added. Then, in the routes configuration file, let's add a get route that runs this method. Finally, back in the signup controller, at the end of the create method, instead of writing this string to the response, we'll return a location header and 302 response code, redirecting to the signup success page. Let's give that a try. Now when we sign up a new user, we get redirected to the signup success page, and there's the link to the login page. There's one more thing we need to fix. If we sign up again using an email address that already exists in the database, we get a database error, specifically an integrity constraint violation because we have a unique index on the email column. So in the signup controller, let's check for this before we try and insert a new record. We can do this by adding it to the validation. We can't use an existing rule from the validator as we need to check the database for an existing record with the specified email address. The Valitron package, however, allows us to add custom validation rules. So following this format, after the existing validation rules that we're specifying in the constructor, let's add a custom rule in which we'll use the user repository to check if a record already exists with the specified value. If this callback function returns true, then the field is valid and the email address doesn't already exist in the database. If it returns false, then the validation message is displayed. Check out the package documentation for more details on how custom validation works. Let's give that a try. Now if I try and sign up with an email address that already exists, we no longer see the error and we see the sign up page with a validation message. If I change this to a different email address, then the validation passes and we can sign up as before. So now a user can sign up for an account, log in, and obtain a unique API key with which they can access the API. There's a link to all the source code shown in this video in the description, along with links to sites shown and relevant documentation. Please don't forget to like, comment and subscribe, and as always, thank you for watching.